Hi all, today I'm going to talk about how we ended with the changing our architecture using the Couchbase in our production environment. So I will give quick information about the agenda. So the introduction I will make, who I am and what is Hepsiemlak, why we need to move from legacy platform to modern platform, what benefits we have seen with the Couchbase, how we transform without affecting data warehousing and the business intelligence, and what's coming next to complete our transformation. So I am Yıldırım Adıgüzel. I'm working at Hepsiemlak as a CTO. In software delivery, almost 20 years experience. I have delivered projects in different domains like e-commerce, technology product startups, internet banking, and the telecommunications. This is my fourth experience with the Couchbase using in the production. Hepsiemlak is the biggest classified company in real estate vertical in Turkey, established almost 15 years ago. We have over 30 million page views in average day and around 100 million events per day. So the transformation decision. So why we need to move from monolith to microservices architecture. So if I give the brief information about this, we had scalability issues, we had development lifecycle issues, downtimes during the deployments, unexpected downtimes, and our software was monolithic, and we had some business continuity problems and the risks. So as most of the system and the platforms have similar problems, so our platform was implemented on top of SQL Server with ASP.NET MVC and ASP.NET Web API frameworks. But the problem was not related with the languages, frameworks, and the database technologies. System scalability was not an issue when it was designed 8 years ago. After application traffic increased organically and the new features were implemented to same monolithic applications, scalability problems were happened. So that's why we need to select other platform or change the design of our software. We had development lifecycle issues like long-running build times, working on the same code base, and adding more dependencies to the same code base, which is causing increasing the development time per feature. For optimizing this, we tried to make the changes in CI/CD pipelines. We applied some branching stuff, but the efficiency of our engineers were not happy about the efficiency. So we had downtimes during deployments because of the monolith structure, and some applications were using the state, and some applications were not using the centralized state management. So we have to deploy our applications during the low traffic, and we need to restart cache, and sometimes it's really hard to warm cache again. And as I told, we have monolithic application. Most of the developers are motivated to implementing the freshly built software. And the microservice approach is popular, I think, about 5 years. As the product teams made the user tests on software and decided to change the UX, this was the great opportunity to change our software design and transform our software to microservices. And the biggest problem was we don't have the disaster center at that time. So establishing a disaster center will be expensive because we try to scale our applications and our system, adding more hardware to our data center. Briefly, these things are mentioned in this part was enough to moving us to microservices architecture. Before starting the implementation, we tried to identify what was our problems and how we are going to solve that. So the multiple data center support is our primary target, and the integration with the other systems like Elasticsearch, Kafka, and HTTPS is the other thing. And we have to maintain our and scale our platform. It should be easy. And the caching and the timer-based everything is the critical operation. And the consistency is the most important part while we are developing. We started seeking solution to remove big risks on our site, which was not having a disaster site. And also, as I told, I had several experiences with Couchbase in production previous years. The multi-data center support is the key item for us moving forward. The solution itself doesn't require any third-party platform to fulfill this requirement. Also, if I look from budget perspective, the solution is feasible. Also, we installed in a cluster on AWS and enabled the XDCR, installed our web fronts to AWS, and route some bot activities to AWS instances. So we tested this and we enabled the active running website with this feature. With this implementation, bots did not affect our customers and consumers. Some parts of disaster scenarios automatically removed from our agenda. So the multi-data center support is really great fit for our environment. While changing our infra, so we were using the Solar, but we would like to use the Elasticsearch because of some specific reasons. Search engine is also another most important part of our platform. We tested the Elasticsearch connector and we were extremely happy with the results. So as the data inserts to Couchbase, it's automatically reflected to the Elasticsearch in a milliseconds. And the operation side is the other thing we were looking for that. I think the Couchbase has the coolest part is the operation and the UI. Adding and removing, managing, and also rebalancing, that kind of features is really cool about the Couchbase. Also, we need to make incremental backups for specific data, which are, our source of truth. So we have to make incremental backup and install if some problems happen in our data center. We need the cache, but also we need the invalidation of the cache. And most of the platforms have same functionality, but the drivers and the clients are not behaving same in all other solutions. So that's why, and we were using the Spring Boot, and the reactive Java client is perfect match with the Couchbase. We benchmarked with the other NoSQL platforms. So, and we selected Couchbase because of this performance thing. And the consistency, I think no need to tell lots of things about this. Couchbase has lots of options for the consistency. And for each consistency level, we have specific applications and really we are happy with using and managing the consistency with the clients. So our platform has content is generating most by the realtors. Generally, realtors working at same time before visiting their customers. And like other customers, they are not really patient. As soon as they update their listings and they are expecting the change will reflect on their portfolio. The old solution was used to proxy caching, and each 5 minutes proxy cache instances was evicting the data, and so this caused some latencies, updating some data. With Couchbase, we don't need to evict, or we don't need to, timer-based cache evicting because everything is in RAM. So, and it's scalable enough to fulfill our, requirements. In old design, periodically, the Solar and the database instances were synchronized with some jobs. This is adding an extra responsibility to software to indexing the data. And each cycle time process is querying the database and updating the Solr instances. Unexpected job failures we had, and we have strongly monitor the jobs are working fine or not. And that creates a poor visibility on our side. That's why, as I mentioned previous slide, the CDC connector of the Elasticsearch, removed some dependencies and some monitoring and some moving parts from our system. And also, some domain objects should be audited. For doing this, either you have to write code in your application layer, which is causing poor transaction management, or you could use the message brokers. Also, you need to write codes for persisting the messages. So with Couchbase CDC, we simplified our implementation, and it's really working great. So how we transfer without affecting data warehousing and the business intelligence. So as I told, this is H company. So if you are transforming an H company, you shouldn't change everything in one time. And it's not very easy to changing everything in one time because the time is limited for us. So, and if you are going to start transforming, you have to think twice about before changing the application. Using the NoSQL systems are cool, but adapting to BI or big data environment is not easy. So that's why and we don't want to change all the business owners' life in the company. So we have to either decide in two options. Using Couchbase SQL drivers to retrieving data, which we need to create some ETLs, some extra monitoring for that, and transforming and moving the data to the BI instances, or we need to install an HDFS for transforming and storing our data. So what we did for this one, in the diagram you see that we have Couchbase instances, and with the Couchbase change data capture stuff, we have Kafka connector. So we are producing the change data to Kafka and consuming with Apache Flume. You can select any platform to consumer as a consumer. You can use Flink and moving data to HDFS. So with this system, we were able to feed also BI environment and the big data environment for in real time and also in proven way. And also with this functionality, we were able to use both transactional and aggregated pre-calculated data with the events. After this implementation, we can add to our product like a price history, some ranking algorithm updates, or sending an instant push notification message to customers who had received the change with the specific message. So if I conclude my presentation, what's coming to next are complete of our transformation. So with the microservices, we created lots of bugs. We have lots of moving parts. And if you don't have good monitoring systems and good alerting systems, I think you had to think again to moving to microservices. And also, this is a part of transformation, which means we have to, transform some data from legacy systems to our new instances. So first of all, some domain objects are stored in our SQL databases, and with the message brokers, we are transferring to Couchbase instances. So get rid of that. We would like to use some new domains as a source of truth in Couchbase. And also we would like to remove SQL Server because of the cost and some functionality. So it has some missing functionalities. I mean, not missing functionalities, but it's really hard to, create an actively running platform. And the license cost of the SQL Server is really high. So that's why we would like to, remove the SQL services. And also 2 years ago, we started this transformation. We were using the version 6, and we were really happy about this one. And we would like to upgrade to version 7. And also, as I told, the search engine is the most important part also in a real estate classified engine. But with this implementation, we have to monitor, and we have to maintain both Couchbase and the Elasticsearch. So, and also we have to monitor the synchronizers between them. So that's why we would like to evaluate and test the Couchbase full text search engine for removing some parts, some moving parts. And also we are using Kubernetes for orchestration of microservices. We would like to evaluate service, Couchbase service in Kubernetes. So that will create, I guess, more flexibility to move some our domains to as a source of truth. And also last feature, I think a few months ago, I read about this analytic service. So we are continuously giving analytic information to our customers. So as a classified engine, so this is something like an ad server. So you have to give lots of insights about visits, impressions, clicks, that kind of things. So, but for fulfilling these operations, we have to create a clickstream engine. And with that clickstream engine, we have to aggregate data, we have to transform data. This is adding also lots of moving parts in our business. So that's why I think it will be great implementation without thinking this data transform and the processing. So this is the end of my presentation. I tried to talk briefly about the decisions and the outcomes moving to microservices using Couchbase. Thanks for listening.